Anywhere a road crosses a stream or a river, a bridge or culvert must be installed to allow that river to continue flowing beneath the road. Ideally, the river ecosystem will not be disturbed or negatively impacted by the road watercourse crossing. On larger rivers, a bridge is usually installed. With smaller streams and tributaries, a culvert is typically installed. This year, Julie and I from the PWA, along with Tanya from Fort Folly Habitat Recovery, have been busy conducting culvert assessments within the Petitcodiac watershed. We have been following the methods established by CARP, which stands for the Clean Annapolis River Project, and Adopt a Stream. Both groups are based out of Nova Scotia. We narrowed down our investigation to the Paulet and Little River sub-watersheds. Both of these flow into the Petitcodiac. Since the Moncton Causeway opened about 4 years ago, DFO and local watershed groups have been restocking the Petitcodiac watershed with salmon, which is an endangered species. So our main focus is the salmon and making sure they can swim throughout the streams and get through the culverts. Using ArcGIS mapping software, we can easily identify all road watercourse crossings in the selected watershed. Once we locate a culvert, we gather the equipment and begin the culvert assessment. Geographic information, such as stream name, road name, as well as UTM coordinates are gathered. We take many photographs throughout the assessment. Some of the water quality measurements are temperature, pH, and dissolved oxygen. We also do a substrate analysis of the stream bed. Channel measurements of the wetted and bankable width of the first pool, riffle, and run are used to calculate the stream width ratio. We gather some basic culvert information, such as the shape and material of the culvert, as well as the length and width of the culvert and the wetted width and high water mark. Next, we set up the survey equipment to calculate the upstream and downstream slope, culvert slope, and the outflow drop. Finally, we take an elevational profile of the tailwater control.
Aquatic species require a certain level of dissolved oxygen in the water in order to survive. And temperature and dissolved oxygen have an inverse relationship, so in the summer months when temperatures get warmer, the level of dissolved oxygen in the water decreases, which can be fatal to salmon and other fish species if they aren't able to reach more oxygenated water sources. By accessing these upper reaches of the stream, salmon are able to survive the hotter summers. Unfortunately, improperly designed or installed culverts can restrict passage, which means they can't access the colder upper reaches of the water system.
One barrier culvert can restrict several kilometers of upstream habitat that fish and salmon alike require for survival and reproduction. At the end of each assessment, the slope, outflow drop, and embedment of the culvert are used to calculate a fish passage score. Ultimately, this score will determine whether the culvert is passable or a barrier to fish. At the end, we're going to make recommendations for every barrier that we find, and we're going to remediate those barrier culverts.